Okay, so we have questions 21, 22, and 23. 21 and 22 use the exact same equation. That equation's rearranged a little bit differently, but other than that, they're very similar. So I'm going to look at, let's see, which one might be more different. Let's just start working through. Let's look at 21 first. So a car accelerates at a constant rate from 5 meters per second to 25 meters per second while traveling a distance of 225 meters. How long does it take to achieve this speed? Okay, so my image for this one is simple. Okay, my image here, what was it, a car? Yeah. We have our vehicle, okay, and we're going some distance, and when we started we're going 5 meters per second. Now when we reach this distance we're going 25 meters per second while traveling a distance of 225 meters. I'm going to choose this starting position to be my origin. How long does it take to achieve this speed? So we are asking time final. Let's make that list. So we have x initial, x final, velocity initial, velocity final, acceleration, time initial, time final. Okay. So x initial is 0 because that's where we chose our origin to be. X final is going to be the 225 meters. Velocity initial, according to our question here, is 5 meters per second, and our final is 25 meters per second. It says it accelerates at a constant, it has a constant acceleration, but we don't know what that acceleration is. And then time initial is going to be 0. And then time final is what we're solving for. Okay. So, I have my list. I found all of my information. I don't know the acceleration. So I need to pick an equation that the only unknown is time final, and that it does not have an acceleration component to it. Okay, so here's my reference sheet. Here's my kinematic formulas. Acceleration is a part of this one. This is an average velocity, and our velocity is not average, it changes. So we can't use that. Here we don't have the acceleration, we don't have the acceleration, we don't have the acceleration. So the equation that we can use is this one here. Okay. So x final minus x initial, because it was delta x, is equal to 1/2 velocity final plus velocity initial multiplied by time final. Okay. All right, let's get rid of our 0 values. X initial is 0, time initial is 0, but doesn't have a time initial component to it. Okay, so x final is equal to 1/2 velocity final plus velocity initial multiplied by t final. We're solving for t final, so we need to rearrange this equation to solve for time final. So let's divide by the 1/2 velocity final plus velocity initial. So time final is going to equal x final divided by 1/2 multiplied by velocity final minus velocity initial. Okay. Let's do a unit analysis. Let's check if we rearrange this correctly. That means we could look at our units here and we would end with units of time, which would be seconds. So x final is in meters. Do that down here. So meters. Okay. And then 1/2 is unitless, so we're not worried about the units there. And then velocity, final velocities are in meters per second. So if we have meters per second minus meters per second, that just leaves us with units of meters per second. Okay? So I'm taking meters and I'm dividing it by meters per second. If I have one fraction, I want to make the other one a fraction. And then anytime we divide by a fraction, that's the same as multiplying by the reciprocal. So meters cancel, and we do in fact end with units of seconds. So this is a great way of checking if you rearranged your equations properly. Okay, so let's plug in numbers. X final is 225 meters. 1/2 velocity final was 25 meters per second minus velocity initial, which was 5 meters per second. Okay. So, let me grab my calculator. Okay. So I'm taking 225. Let me show you how I would do this. You don't have to, but if you're going to plug it in all at once, I'm going to say that I'm taking 225 and I'm dividing it, and I need to say everything that's on the bottom of my fraction, and so I'm going to put a parenthesis there. So I have the 1/2, which I could put in another parenthesis as a 1/2, or I could change it to 0.5. So 0.5 multiplied by 25 minus 5. Okay, so I'm closing that. Oh, minus, it should be plus. Because I had plus there, I divided by the plus. I'm so used to doing final minus initial. Okay, so plus. Okay, so I'm closing that, and now I'm saying this is everything on the bottom of my fraction. I'll run that number. Okay, we have 2 sig figs. Oh, we're adding, so it's digits after the decimal place. So that would be 30 dot. So that'd be 2 sig figs, 3 sig figs. So our final answer here. And sig figs get lost easy on this one. And so know that for items like this, we're using this equation on the test. Give me a reasonable answer, but I'm not going to be docking you for sig figs. Okay. So that would be 15, and time has units of seconds. Okay. All right. Now, we have a motor scooter starting at rest and speeding up at 3.5 meters per second squared, so that's an acceleration. After the traffic light turns green, how far will it have gone once traveling 25 meters per second? So that's, that would be a different equation. So let's look at that. Okay, so we have a scooter. It's accelerating from rest. Okay, so we have our scooter accelerating from rest. We're going to go some distance. How far will it have gone when it's traveling at 25 meters per second? So we want to know this x final there. I'm going to choose my origin to be here. Okay, I'm going to say that's my positive direction. So let's make our list. X initial, X final, velocity initial, velocity final, acceleration, time initial, time final. Okay. Velocity initial, it's at rest, so that would be 0. velocity final, it's going to be the 25 meters per second from the problem. Acceleration is 3.5 meters per second squared. Time initial is 0. And then we don't have the time final. Yeah. Okay. All right. So, we don't have a time component, but we want to know how far it's gone. Okay. So when I look at my equations, I can't use this because it has the time component. Can't use that for the same reason, same there. So my only equation is this one. So I have velocity final squared is equal to velocity initial squared plus 2 times by acceleration times by delta x. So I can see how much. Okay. So velocity initial is 0. X initial is 0. Velocity final squared is equal to 2 times by acceleration times by x final. I'm solving for x final, so I'm going to rearrange this equation to solve for that. So I'm going to divide by 2 and multiplied by acceleration. So x final will equal velocity final squared divided by 2 times by acceleration. So that would be 25 meters per second squared, 2 multiplied by 3.5 meters per second squared. Okay. So x final would be 25 squared divided by 2 multiplied by 3.5. Okay, when I plugged that in, do you see that I put that in parentheses? I want to keep all of that on the top of my fraction. Okay, so my final answer is 2 sig figs, 2 sig figs, 89 meters. Okay, well, let's keep going on to the next one in the next